Bismillahirrahmanirrahim. Hello everyone. Good evening. Uh, Last time we discussed hydrocarbons. Okay, and specifically we learned that hydrocarbons are the simplest organic compounds, and we categorize it alkanes, alkenes, and alkynes. Okay, so on what basis we categorize hydrocarbons into three types? Okay, so today I will discuss alkanes, alkenes, and alkynes. Uh, we categorize hydrocarbons on the basis of covalent bonds. Okay, if there is a single covalent bond exists between two carbon atoms, so we call it alkanes. Okay, and these alkanes are saturated hydrocarbons. Saturated means they are saturated, they are less reactive as compared to other two types. Okay, and the second point is only single covalent bond exists between carbon atoms, like such as methane, log. This carbon atom is covalently bonded with four hydrogen atoms, and between them only single covalent bonds are exist. Okay, look at to ethane. Same is the case here. Two carbons are bonded with single covalent bond, and the rest of the hydrogen atoms are also bonded with single bonds. Okay, like propane, the three carbon atoms are single covalent bonded to each other, and respectively the hydrogen atoms are also single covalently bonded to each carbon atom. Here and alkenes, these are called unsaturated hydrocarbons. Unsaturated means that they are more reactive than alkanes. Unsaturated means they are more reactive, because here and between carbon atoms there are double bonds present, and these double bonds are represented with these two lines. Okay, and alkenes at least one double bond or exist, such as look at to the ethene formula. This ene is represented by this double bond. Okay, look at to ethene. Here these two carbon atoms, and between them there are double covalent bond are present. Bond is represented by ene. So ethene is the first member of alkenes. Okay. Look at to propene. Here is also a double bond is present in between two carbon atoms, and same is the case here. Look at to this formula of butene. Okay, four carbon atoms are present and at least one double bond are present in between these two carbon atoms. Alkynes, this YNES is represented by these triple bond. Okay, so in between these two atoms there are at least one triple bond are present, so these are called alkynes. These are also unsaturated hydrocarbon. At least one triple bond exists and between two carbon atoms, such as ethane. Look at the formula of ethane, and also propane, butane, pentane. These are the three types of hydrocarbons. So, the first member of alkane is methane. The formula of methane is CH4. Our second member of alkane series is ethane, C2H6. Third member is propane, C3H8. Fourth member is butane, C4H10. Pentane, C5H12. Hexane, C6H14. Heptane, C7H16. Octane, C8H18. Nonane, C9H20. Or decane, C10H22. Okay. Uh, uh, and alkene, the first member of alkene is ethene. Sir, why? Why not methane? Methane. Because methane contain only one carbon. And alkene, for double bond, we must need two carbon atoms. So that's why alkene homologous series is start from ethene. Okay, and the formula of ethene is C2H4, propene C3H6, butene C4H8, pentene C5H10, hexene C6H12, heptene C7H14, octene C8H16, nonene C9H18, and decene C10H20. Okay, look, the difference between alkene and alkane is only what here. An ethane, two carbon atom and six hydrogen atom are present. But here an ethene, two carbon atoms are present, which is the same case with alkene. But here it lack two hydrogen atoms from alkane. Okay, and ethane H6 are present, while an ethene H4 are present. So these are minus two hydrogen atoms are always present in alkenes. Okay, in ethane C2H6, while in ethene C2H4 are present. In propane H8, while in propene H6, lacking two hydrogen atoms. While in alkyne, ethane is the first member. Okay, and its formula is C2H2. Look, it is also two hydrogen atoms lacking from alkene. And alkene, the first member is ethene, and ethene's two carbon atoms are present, and four hydrogen atoms are present. But in ethane, two atoms of hydrogens are absent. Look here, H4, four hydrogen atoms are present, while in ethane two hydrogen atoms are present. And that's why, and this is why, because here double bond are present, while in alkyne triple bond are present between two carbon atoms. Okay, the second member is propyne, C3H4, C4H6, C5H8, C6H10, C7H12, C8H14, C9H16, C10H18. Okay, so note it down. We define that organic compounds are those compounds which are composed of hydrocarbons and their derivatives. Okay, so we discuss hydrocarbons. Now I am focusing on its derivatives. Okay, so okay, according to this definition, Hydrocarbons. We already discussed about it that these are alkanes, alkenes, and alkynes. Okay. Now I want to teach you people its derivatives and their derivatives. Derivatives are a group of organic compounds that derive from these hydrocarbons. Okay, or we can say that some of group of atoms binds to hydrocarbons, so their properties are changed. Okay, we know that the formula of methane is CH4. Okay, sir, we know that. Okay, if I remove this hydrogen atom from this point and attach some other group of atom or simply an atom other than carbon and hydrogen, for example OH, are bonded here. Hydroxyl group, this group of atom are called hydroxyl group. If it attached to methane, so now it's not a methane, it's a different compound. We call it alcohols. Okay, because this hydroxyl group changes the properties of methane. Okay, we call it methyl alcohol. Methyl alcohol. Suppose I take ethane. We all know that ethane contains of two carbon atoms plus three hydrogen atoms to each of the carbon respectively. This is the chemical formula of ethane. If I remove these hydrogen atoms and bind a different type of atom, like I take halogens, from halogen group I take chlorine. Okay, I take two chlorine atoms and they binded here, so now this is not ethane, these are ethyl halides. We call it ethyl chloride. Okay, so here this group of atoms and here these atoms changes the chemical and physical properties of these hydrocarbons. We call it functional group. Okay, so if now I defined a functional group, you people have some idea about the functional group, and its functional group are derivatives. Okay, when they attach to hydrocarbons, these hydrocarbons changes its chemical and physical properties. Okay, so now I am defining the functional group, so note it down that I may continue my lecture. So functional group. What are functional group? Okay, the term means that functional group may be an atom or it may be a group of atoms, so we can define it. An atom R group of attached with R that is responsible for the specific properties of inorganic compounds. Okay, like if I take CH3, CH2, CH2, look, 1, 2, 3, 4. Okay, so if I bind functional group to carbon number 4, and here I bind chloride, so this carbon number 4 is now what it is. This carbon is actually R. Okay, it represent by, we represented it by R. This is the reactive portion where a different type of atoms attach. Okay, and this atom completely changes the chemical and physical properties of this molecule. So we call it functional group. Okay, hope it is now easy for you and you can easily understand what is a functional group in organic compounds.